The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. And the topic of today's session is Chips for Wearables, when function meets passion. Our guest speaker today is Santosh Shivdatta. He is the Technical Director with Mindtree. He is currently Director and Head VLSI Services at Mindtree. He has more than 17 years of experience in VLSI in developing complex design IPs and SoC development. He led Mindtree's Bluetooth controller IP development program with multiple first-pass silicon to his credit. He thrives in the confluence of VLSI, embedded software and systems, and has specialization in areas of short-range wireless, low-power design. So, without further delay, I introduce you all to our guest speaker. Over to you, Santosh.
Good evening, everyone. This is Santosh from Mindtree. I'm leading the VLSI services business here in Mindtree. So today's topic basically is on chips, chip design for variables when function meets passion. So in summary, just to give you a brief overview, this session will cover some ideas about how to take care of chip design considerations when you're designing chips for the wearable market, and a kind of a framework of how do you derive some of these parameters that will influence when you're designing a chip. Let's just start by kind of looking at a very broad definition of what is wearable electronics. Everybody today is talking about wearable electronics. It was the most discussed topic in the CES or the Mobile World Congress that recently concluded. So everybody's talking about wearables and wearable computing and wearable electronics. A very broad definition of wearable electronics is, like the name says, it's electronics that you wear, but it also helps you do two functions. It helps you sense, your environment, your activities, your body parameters, and collect those sensed data and, use that for some processing. And once the data is processed, the second function is to bring back that processed information and, bring it back to you as some alerts or information that you can use. And why do you need to do that? It's just that you want to improve your health, or you want to be able to monitor something so you have an improved productivity. Basically it's to improve your lifestyle, so to say. So basically, if you look at today the market for wearables, there are various kinds of functions that today you will see. Activity monitoring. You're a sprinter, you're a jogger, then you would want to monitor how many steps, how many runs you have made, how many kilometers have you run. If you are, under therapy, then you will need some kind of a chronic care. Then you need some kind of monitors, like a blood glucose monitor, to monitor your blood sugar levels, or tracking, tracking your assets, tracking your pets, tracking your kids, or it could even be navigating in a small environment, in an indoor environment. So there are various functions that you can think of that these variables will support. But this is just one degree of diversity. The next degree of diversity, or the second degree of diversity, is in terms of form. Today variables come in various forms. If you look at a body, then you can look at it as a real estate, and you can look at variables in the form of hats, in the form of an earbud or an anklet or a watch. And shirts and shoes, and people are thinking of new ways of putting their electronics on your body, and in various forms and form factors, and that's really again a second degree of diversity that you see in this market. And really the third degree of diversity in this market is about the people. You know, if you look at the diversity, the demography of people, you know, unlike a lot of the use cases that or the products or the market segments that you've seen till today, for example, you take the market for smartphones. You know, smartphones, you know, it's the same form factor. You know, it's maybe, you know, the length and the breadth is probably slightly here and there, but, you know, it's almost the same form factor. That's not changed for years. Of course, there are a lot of functions that get integrated, but then everybody seems to have the same functions. But unlike any of the market that we have seen in till today, you know, this market is going to be driven by people who are, you know, spread out, you know, in terms of, you know, you could have a baby that requires some kind of monitoring. You know, it's a newborn baby and you need some kind of a monitor just to make sure your baby is monitored, you know, when you're in the hospital, to young people, to aged people. For example, you know, my father, for example, may need it to monitor, you know, his blood sugar levels continuously, for example. So there's a whole diverse set of people that will use it. It's you know, it's so diverse. You know, it's celebrities, it's workers, it's people in corporates, people who are professionals. You know, so you break it in any different way. You know, everybody has a way to look at it. You know, it's all driven by a self-expression. You know, it's about your individuality. It's about how you express yourself that drives, you know, what kind of a variable. Because people would look at variables like the way they wear jewelry or anything else. So they would want to look at it as something that kind of represents themselves. So it's kind of a fashion statement. So if you look at this whole diversity that is brought about by you know, various functions that you need to support, the various form factors that are potentially possible, and the kind of, you know, different mindset and different kinds of people that you need to address, you know, suddenly you will realize that wearables is a market that's completely unique. It's never been like this before in any industry or any market segment that you would have seen today. So it's a very diverse, very universal kind of a market. And wearables is about not just looking at individually about function, form, or fashion, but actually it's about bringing all of them together in a fusion way. And, you know, somebody who is working in this market should actually be able to combine all of these three together and have a kind of a holistic view of function, form, and fashion to be able to address this market than any other market that we have seen. So really, what is driving this market today? You know, why is it so popular today? Why is it that it's suddenly become the in thing? If you look at from a technology angle, broadly there are three technologies that kind of have over the years kind of converged, developed, and have come together today to enable this market. The first thing is about the human-machine interface, sensors. You know, the sensors have, you know, now today you get a whole lot of sensors that you can have sense, you know, you can build sensors for right from, you know, sugar levels to environment to temperature to a whole lot of parameters that you can now today sense. And all of them have become easy to implement and also become low cost. The second converging factor or a technology factor that's come about is computing. It's become cheaper to put in a lot of power into computing in a small area. You have processors like Cortex-M, you know, and the different MIPS and a lot of different processors today which give you a lot of processing power that's required to be able to process a lot of information that you collect from your sensors. And the third technology that's converging is connectivity. So today you have standards like Bluetooth Low Energy or Zigbee, which are becoming standardized and enabling a lot of new products to come in with this connectivity already enabled. And now it's about how do you use that connectivity to enable your wearables market. So all of these three technologies, you know, human-machine interface, computing, and connectivity are converging together to enable this market. And all of them have come to a cost point, and in terms of power, in terms of performance, have really come together today to enable this and drive this whole market. But if you look at all of these are all technologies. But what is really finally what is driving this market? Where is this convergence happening? And if you look at that, there's probably just one single thing that comes to mind that's driving this whole market, and that is these low-cost and low-power microcontroller chips. That's where the convergence of all of these technologies is happening, and that's single thing about microcontroller chips is what is driving this whole wearables market. Now, you need to understand, if you are a chip designer or a microcontroller designer, what is the kind of market that you're really kind of addressing. As a chip designer, there are a whole lot of companies today who make these microcontroller chips, from Microchip to Freescale to Texas Instruments to Silicon Labs, a whole lot of them. But you need to understand that they are trying to address this market where there are this whole bunch of products which are so diverse. And not only that, these products have their own unique requirements in terms of what functions they do. For example, one could be used as a watch to monitor, your activities. The other could be that it's a earbud that, lets you take some commands. So there are various use cases that people have, and all of these products come with different use cases. But it doesn't end there. These chips have to address finally these end consumers, and as I said before, these consumers have their own priorities, requirements, and style statements that you need to address. So as a chip designer, you need to understand that unlike, again, the previous markets that somebody would have worked for, it's such a diverse market that you need to think of yourself as designing something that will have to radiate into these multiple products and consumers from where you start. So that's really the challenge today these microcontroller companies will have to address, is about how do you radiate into this so much diverse market. So today's session is basically about trying to look at, from a chip manufacturer or a chip designer's point of view, how do you really address this market? What are some of those parameters that you can kind of think of in a very generic way and still be able to address this so many diverse requirements that you will come across. So what I'm going to present is initially a framework that will kind of make it a little more easy for you to address this market with a common set of attributes that can define this market. And how do you measure these attributes with a set of parameters? And with these attributes and parameters, what is the play that they have in a chip design process? And use that framework to kind of see how you need to think as a chip designer, and some of the examples in the industry of how people have used those design techniques to be able to create chips for the market. If you look at what are the top or the key attributes that define these wearables, we looked at all these segments of different products, different end users, and different functions. All of them can be defined or attribute, can be easily classified if you just could address this market by looking at these 4 attributes. First thing is, it's all about getting personal. Wearables are all about personal statement. So you need to understand that when you look at this market, that whatever you design, whatever you're developing has to be addressing this requirement of being personal. Second, it's about being always on. People would want to use this, for 24 hours. It's always going to be on. You could have, somebody's health being monitored throughout the 24 hours because you don't know, for example, it's a heart rate you're checking because, somebody could get a heart attack. So you need to be continuously monitoring to see where, to check for any signs of any problems. So, more and more, some of these products will have to be always on. The third factor is about convenience. These products have to be very convenient for users. Unlike even a smartphone today, right? You have to do so many things to be able to get to a specific use case or do something. These wearables have to be so convenient that people will just use it and they won't even know that they're having this wearable on them. So that's a very key, again, a parameter about any of these wearables. And last is about being connected. These wearables have to be connected, and there are various angles to how it has to be connected, and we're going to slightly go into some of those details. So if you can look at these 4 attributes and then break it down into the parameters that you can measure these attributes with, then that's the kind of framework that we are looking at. Now let's look at each of these attributes and see what are the parameters that define these attributes. First thing is about personal. The first thing is it has to be personalizable when we say it's personal. That means, like your phone, you need to be able to choose what function it has to do. You need to be able to choose its configuration. You need to be able to choose, whether it's on or off, or a lot of things that So you need to enable a lot of personalization with this product or with the chip that you would design. The second thing is about multifunctions. Today, unlike if you look at wearable, wearables is not a new technology or a new thing. You have had wearables like watches that my fathers used to wear. That's a wearable and it has been there. But if you remember the watch, it just did one function, which is to show you the date and the time. That's it. But today's wearables, people expect it to be multifunction. I need to be able to use that for jogging, but when I come back home, I should be able to see if my kid is awake, something like that. Or I'm using it in my car, I will also be able to use it in my office for something else. So the same device should be able to support multiple functions so that people can use the same wearable device in different ways. And the third aspect of personal is really the challenge of maintaining privacy and security of your information, because a lot of these wearables would be collecting a lot of data that's very personal. It could be about your health, it could be about a lot of things that you don't want it to be exposed or available to people outside. So when you are designing for this market, you have to understand how do you address the security and the privacy issues, right from a chip design level all the way to the product. The second attribute we talked about was convenience. The first parameter you have to look at there is human interface. Now I specifically don't call it human machine interface because from a product point of view, you have to always look, this is a wearable, so you have to look at it as a human interface. So even buttons are not human-like interface. When I say human interface, you have to look at it as human-like interface and not coming from a machine's angle. It's easy for a machine or a phone to put a button, but is this how a user works? May not be that. So you have to look at it like human-like interfaces to make it convenient. Whether it is gestures, whether it is eye movement, those are the kind of things that we need to be probably thinking of to address convenience. The second thing is called context awareness. That's exactly how humans or human brain works. If you, for example, see a fire and a smoke, right? You smell a smoke, somewhere you see that something is burning, but you also see that, there's fire. So you have a context that your brain processes that, yes, I am seeing fire, but I am also smelling something burning, maybe a rubber or something. So then using the context of the smell and your sensing of the fire, you kind of make judgments, make decisions. So it's true about human brain that you get multiple sensor inputs, derive a context before you make a decision. So it's important that today's or tomorrow's wearables have to be able to give the context awareness to people. It's not just one sensor doing one job, but multiple sensors, and how do you combine or create a sensor fusion to kind of derive the context in which you're operating. And the third thing about convenience is also about being unobtrusive. You shouldn't even know that you are wearing a wearable. You shouldn't even know that it's on your body. It has to be very unobtrusive in terms of your being aware of it, or your somebody whom you work with is also aware of it, because it has to be like almost in the background. The third attribute is about always on. Again, here there are multiple parameters, but I picked up the top 3. One is about continuous use. These devices will be continuously used. They will be continuously monitoring your body parameters, your environment, your physical, and maybe there are sensors tomorrow which will also monitor your emotional conditions. Whether are you stressed out? All of these parameters have to be continuously monitored, because there could be use cases that require you to continuously monitor process that and create patterns or inputs that you will have to work with. For example, as a lifestyle, you start your day, you drive your car, you come to office, and you have a lot of meetings and you're stressed out. So your wearable should be able to tell you when you are stressed out and give you inputs to tell you, how to calm down and then go on with your work. So the second thing is about energy. Energy is about, people don't want to, come back home every night and charge this device. Today Samsung has a watch, and as I hear in the market, every day you want to come back and charge it. So people don't want to be able to charge this every day. They want this wearable to run for, many, many days. In fact, I don't want to charge at all if it's possible. The other aspect of energy is also about, wearables are very close to your body. So you cannot generate too much heat, because over a period of time, whether it's small heat, it will add up, accumulate, and then people will be able to perceive this heat. So you need to be able to manage energy dissipation, not just consumption, but also energy dissipation to make sure that people are able to comfortably wear this device. The third aspect of always on that you need to be aware of is it also has to be real time. That you need to be able to process sometimes data that's coming that you're sensing and able to give inputs in real time. The fourth attribute is about being connected. Of course, we talked about connectivity, connectivity to your smartphone, for example. You need to be able to connect it to your smartphone easily. But it's not just that. You may have wearables from different companies that you have bought. You may want those wearables to talk to each other. You may have a watch, you may have a pendant, you may have an earbud. How do you enable them to talk to each other and maybe exchange some information that's useful and create some context awareness between themselves? So connectivity is not just about networking with connecting up to a host device, but also internet-working between different wearable devices. The second aspect of connectivity is really about social. Today everybody talks about LinkedIn. Social is the in thing, and if that is expected to continue, then you would also want your friends to know what you're doing now. How much is your activity levels today? What are you doing at this moment? All of those informations you may want it to be available either real time or be able to upload it and available for your friends, and then for your own analysis also. The third aspect is also about locationing. You should be able to have, like we said, about real time and being awareness of the contexts. You also need to be aware of your location. Location awareness is also becoming very important as a variable. For example, if you are entering a shop, a retail shop, then based on your parameters inside, then the variable should be able to tell you, for example, how do you navigate. Maybe there is an advertisement that comes on your variable to say, based on your social, parameters, it will tell you, this is the place where you need to go and buy, what you've come to buy. So you should be able to locate where you are. Either it's indoor or it could even be outdoor navigation. You may need to combine your GPS data to be able to say where you are. For example, you have an elderly person in your house who is suffering, say he's on a walk somewhere, he falls down, for example. He carries a stick. It's a wearable. He is carrying a stick. So when he has a fall, the wearable should be able to detect the fall, but then using GPS, it should be able to tell, this is where he's walking and, that's where he fell down, so you can come and pick him up. So it should be able to tell it automatically. So location awareness, whether it's indoor or outdoor, is again important as a connected. So what do you do now? You have all of these attributes, you have all of these parameters that you have to consider as a chip designer, and you need to be able to balance all of these to be able to kind of design the right kind of chips that will address this market. So how do you go about doing that? So you have to first of all understand that it's an interplay of all of these parameters. While some parameters may, kind of enable a specific design process, the other parameter may actually drive you in the opposite direction. So it's all about what compromises, what choices you make based on what parameters you really want to address and what attributes you are trying to really address. If you look at from a chip designer point of view, there are 4 different aspects of chip design that you have to address. And what you really need to do is to look at all of these parameters and attributes and see how each one of these parameters is trying to kind of drive your chip design process. The first thing that as a chip designer that you need to take care is about, or you need to look at, is about your compute power and storage. And there are different parameters. For example, if you look at locationing, you may get a GPS data, then you may have to process that data. So do you have enough compute power to be able to process this location information? We talked about contextual awareness. So that means you need to be able to collect data from different sensors and then combine them in a way that makes sense. So for example, how do you just take input from an image that you captured and a environment parameter like temperature that you measured, how do you combine them? What is the meaning that you extract? So that requires a lot of processing to be able to do. So if you look at what kind of markets you are trying to address, what kind of product you are trying to build, and what parameters are required for that market, then you'll be able to see what kind of compute power, what kind of storage that you need to bring in to your chip. The second parameter as a chip designer you look at is energy management. All of us today know about low power, and we bring in a lot of infrastructure into the chips to enable power save. And again, you need to look at what are the different parameters that will drive this. For example, continuous use. If your device is going to be in continuous use, then it means you need to build in a power management strategy that can take care of the user's patterns automatically. You don't want a user to say, I'm now going to be on, I'm now going to be off. He'll not use any buttons. So how do you know if a user is actually using? He's actually sensing. If he's not, then how do I automatically shut down? How do I know when he again wants to use it? How do I again bring it back? So how do I do an automatic power management, as I go along? So all of these parameters, not just infrastructure, but about how do you really overall manage power, is the second aspect of chip design that you have to consider. The third aspect is about human-machine interface, or HMI. Again, here you need to look at what kind of user interfaces you are trying to bring in. If you look at, for example, multifunction. So if you are looking at a device supporting voice commands as well as supporting temperature sensing, then you need to look at what kind of HMIs I need to build in. Do I need a speech codec? Do I need an ADC? What are the kind of sensors? And tomorrow you might have different kinds of touch interfaces. So do I need touch sensing? So you need to look at what are the different kinds of HMIs that you need to build in to your chip to be able to address some of these parameters and attributes. And lastly, you need to also look at connectivity in terms of what kind of short-range wireless connectivity, whether it is Bluetooth, but beyond short-range wireless, you also have to look at other technologies like GPS, or you need to bring in wireless LAN if you want to directly connect up to a, internet, without going through a smartphone. Then you may need a wireless LAN connectivity to kind of upload directly to the internet. So you need to look at all of these connectivity parameters and design your chip for that. So broadly, if you are a chip designer, to summarize, you need to look at the framework of what are the attributes, what are the different parameters that define these attributes, and then as you go into your chip design and address these four aspects of your chip design, you look at all of these aspects and attributes and see how each one kind of pulls in each direction and go about your chip design process. It may not be the way that today's chips do, but this is the framework that you can work with, looking at the diversity of market. What you can look at is, let's take some examples after we go through a summary of some of these parameters that you need to look at. So if you are a chip designer today, my recommendations of top 7 things that you need to think about as a chip designer. Number 1, look at hardware accelerators. There's not going to be enough compute power to take care of a lot of different computing requirements that you will have. So you need to bring in a lot of hardware accelerators. For example, if you are looking at security, you have an AES engine that's running in hardware. It could even be a DSP, a small DSP that needs to process a lot of the signal processing that you need to do on your sense data. So you need to really look at beyond your main processor or the app processor, what other hardware accelerators that you need to bring in. The second thing that you need to consider is what amount of on-chip flash you are bringing in. The size is important in terms of how much data you need to store, how much data you need to process. You may need to determine the size, but also partitioning is important in terms of you may have different areas depending on your security requirements, depending on what kind of data you're collecting, what kind of data you want to expose, what is data you don't want users to kind of write. You may also have to look at how do you want to partition your flash, which is on chip. The third thing is about analog interfaces. Of course, it's very much required, ADCs, DACs, and comparators, but you may want to look at making them programmable, because today you don't know what kind of user interfaces people will use your chip for. So you better have it as very programmable, where users can kind of program your analog interface to match with the sensing that you are trying to do with this chip. The fourth aspect is flexible serial protocol interfaces. Today's chips already have a lot of UARTs and SPIs and a lot of different serial interface protocols. But what you need to probably look at is in terms of their flexibility itself, do they support multiple different combinations of uses, and even looking at having a common platform-like interface, but then making it programmable based on whether you want to use it as a UART or an SPI or a different kind of a serial interface. Instead of having multiple different interfaces, having one as a platform interface and then making that kind of flexible. The other aspect is on oscillators and timers that enable you to do power save. That's again a key requirement. The sixth is about automatic power management. Today a lot of chip companies build in a lot of infrastructure for power management. You bring in oscillators, timers, low power, power gating, and a lot of different techniques are brought in as an infrastructure. But what you really need to look at as a chip designer is how is it actually being used? Have you looked at use cases of how will, for example, an automatic power cycling will happen? And are you really fine-tuned? Are your infrastructure really available to for a user to actually take it through a power cycling in a very efficient way, or you've just thrown in a bunch of pieces which really don't tie well together when you really want to do a power save? So really you have to look at this kind of an automatic power management beyond just bringing in the right infrastructure. Short range wireless connectivity, today we have Bluetooth low energy, but beyond that, anything else you need to think of. Beyond the technology, I think the very important piece is the topography in terms of whether it's a single connection, whether you will have multiple connections. You need to support whether your device is going to work as a slave or it's going to work as multiple slaves to multiple devices. So all of these topologies have to be thought through beyond just the technology that you bring in. Let's look at today, some examples of, some of these products in the market that we have today, and see, how some of these parameters that we looked at and how they have probably been considered in these chips. Here is an example of a Freescale KLO2 chip, and if you see, there is a Cortex M0 processor, so that takes care of your compute power. There is a 32 kilobytes of flash on the chip, and in terms of interfaces, it's just got a very basic ADC and a voltage comparator. In terms of power management, it's got a low power timer built in, and in terms of interfaces, it's just got a simple low power UART and an SPI. So it's a very basic connectivity chip. It does not bring in any short range wireless connectivity. So it could be used for some very basic, simple, wearable use cases. Take another example from Freescale, which is a KWOX. If you compare that with the previous chip, suddenly you will see that there are a whole lot of timers that this chip has got. It's got periodic interrupt timers, low power timers, so that enables you to do a lot more power management and also cater to a lot of different use cases. It's got a DAC, which it brought in a 12-bit DAC, and a lot of new interfaces and more interfaces that have been, like touch sensing, that have been brought in. So again, so this addresses a much wider market compared to the previous chip. Let's take a look at a different company, Silicon Labs, and look at how their chip looks like. So from a basic storage and processing compute power, it's got all the basic elements that you typically have. But if you look at their clock management, they've got a bunch of oscillators that they have brought in, low power oscillators and RC oscillators that they have brought in to address a lot of the low power requirements. And if you see, a lot of their energy management units are also there to enable it more towards a very low power kind of use cases. I was talking about hardware accelerators. You will see here that they have got an AES engine brought in as a hardware accelerator to support a lot of security use cases. A little advanced chip from the same company, you will see the difference is that they've got a lot more timers and a lot more interfaces, again, to address different markets. So really, if you look at today, it's an evolving market. There are multiple companies, multiple product lines. So where are we headed as a chip designer? You know, what are the things that we need to be tracking to make sure that we are in sync with the market that's emerging? These are my own predictions. Like all predictions, you know, some of these may come true, some of these may go wrong. But you know, here is my take. Number one, hardware accelerators will become necessary. So you better start looking at what functions, what features you need to bring in, and start looking at building some of these hardware accelerators beyond simple AES engines. 32-bit processors will become de facto, whether it's Cortex M0 or any other, but you will need 32-bit processing to be able to manage the kind of functions and feature set that's required. Third, energy harvesting will become an in thing for chips as we expect more and more of these chips to live a very long life. Just to briefly tell you, for people who don't know, energy harvesting is about how do you use ambient energy and convert that into electrical energy and use that so you actually almost completely remove the battery from your product. Fourth is about some of these devices will more and more get connected directly to the internet without a smartphone. That means you will have 3G connectivity coming directly onto these wearable devices, and you don't need a smartphone to connect and upload your device. As a corollary, it could also happen, or it will also happen, that some of these functionality of today's wearables, for example, you have a lot of these products which do activity tracking. They might get integrated with the smartphone, and some of these wearables will markets today that exist will actually vanish away because some of these actually got integrated with your smartphone itself. A lot of hardware sensor hubs will become important as you look at context awareness and bringing in a lot more sensors. So people will have to look at sensor hubs as part of not just connectivity but also sensor hubs. In my view, Bluetooth Smart is going to be the technology that will win this market in terms of connectivity technologies. People will have to look at designing chips that will almost look like platform on a chip and bring in a lot more programmability at a software level, because like we saw, there is so much diversity in the market, use cases, that you cannot start building chips for every different market segment. So you need to be able to build a common chip that can address multiple markets and bring in a lot more programmability at a software layer to be able to address this kind of a market. Wireless charging could be an in thing in terms of not having any wire to be able to, because you just want to be able to bring in your wearable, place it on the charger, and you should be able to charge it than actually having to connect a wire to actually charge every time. And lastly, more and more these devices will become smarter in terms of having more decision-making capabilities, local decision-making capabilities available instead of going all the way to a smartphone or to the hub to make the decisions. And a lot of data aggregation will happen so that you only send relevant information up to your host and aggregate a lot of data at the wearable device itself. So what does Mindtree's play in this space? We talked about a lot of chip design and a lot of things, and it cannot all be done by one single chip company, multiple chip companies, but they will also need a lot of support and IPs from ecosystem partners. Today, Mindtree has IPs in this domain. Bluetooth Smart, Mindtree is a leading IP provider for controllers, stack, and profiles. Mindtree is building a reference SoC for wearables called KWOX. We have a lot of hardware accelerators like AES engines that we have built that are licensable to customers. Apart from IP, we have low-code consulting expertise through our experience in the last 10 years in various customer engagements, as well as building our own IP and taking it to market. We bring in a lot of low-code consulting expertise. And of course, from our VLSI services, we offer a lot of different services for chip guys to be able to take their chips to market in terms of derivative IC engineering or platform application software development, or in terms of consulting on the right chip architecture for your chip. Lastly, where is this wearable market headed? And there are some interesting paradigms that might emerge as we go. For example, what can we predict about chip design cycles, having to overlap with fashion cycles? You need to think of wearables as, like you said, individualistic. It's about self-expressions. And so a lot of fashion cycles could drive, what people are wearing, what kind of devices today is in the market, and what could change. So as fashion cycles change, you suddenly have to also adapt your design cycles to adapt to your fashion cycles. So what is the new processes, what new methodologies will you have to bring in to kind of, create this overlap of your own methodologies and cycles and meeting up with the fashion cycles? You would have to probably look at completely new human interfaces and interaction guidelines and rules that will get defined that you don't know today. That will be driven by the consumers that you will have to cater to. Who knows, today it's consumers who are driving the market, and tomorrow it could be enterprises that completely take over this market. You could, for example, have employees having to, instead of having badges, they just come with a wearable, and it has a lot of data about them, about their security and a lot of things. So employees are provided with a wearable watch or something that they come in with that tracks their health. Are you actually being very active, and sponsor a lot of health initiatives for people who are not active. You don't know how things will emerge. And a lot of enterprises could come in and bring in a lot of stake into this market. How do changing form factors? You're today looking at wearables which are like watches, it's still big, but more and more you are looking at implantables, just under the skin wearables. Of course, there are also people talking about wearables that will, that you can actually swallow and then actually track some of your internal activities, but that's still too far and people may not like it. But you're not probably too far away from implantables that you want. So what kind of form factors will be required? Then in that case, what kind of packaging you will have to look at? Is it bio packaging? Is it, what kind of packaging, biodegradable packaging? What kind of packaging does these chip companies will have to look at? Also, in terms of your own chip design cycles or designing products for this market, you don't know what kind of other interdisciplinary approaches that you need to take. You may have to work with biologists. You have to work with fashion gurus. As you are a chip designer, suddenly you are bringing in different disciplines to come to your chip company and help you design the right chips. That could be another trend that emerge. And lastly, it's about also solving a lot of paradoxes that will emerge in terms of people want to be private versus social, people who want something which is functionable but yet fashionable. How do you address all of these paradoxes that might emerge and really address this market? But beyond all of this, the way I look at this market in one simple word or one simple phrase is this really finally the sixth sense? People talk about having five senses, and you sometimes talk about have a sixth sense. But then, is this really going to become the dependable sixth sense that everybody talks about in a real form? Thank you. That's all I have today, and I can take some questions.
Thanks for the insightful presentation, Santosh. As you just mentioned, let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to your insights.
Okay, just give me a second. So there's a question on, the question is, chips for wearables means are these chips on humans? Yes, of course, that's what we are talking about. It's about a wearable device, not directly the chip itself, but we are talking about chips to be designed for products which are wearables. So it's not the chips itself, just to clarify the title, if you have been confused about the title. Are there any other questions?
Yes, so there's a question from Santosh Krishnan. He's asking, is there any ICs that have a sensor connectivity things embedded in it?
Sorry, I can't see the question. Sorry, can you repeat the question, Aradhana?
Yes, so the question from Santosh Krishnan is there any ICs that have a sensor connectivity things embedded in it?
Yes, as we went through the presentation, so the question is about, just to repeat for the rest of the team here in Mindtree also, are there any ICs that embed sensors and connectivity today in the market? Yes, of course, there are a lot of chip companies that come with connectivity. For example, I just showed a chip that had a sub 1 gigahertz transceiver. There are also a lot of chips which have Bluetooth smart integrated today. And of course, sensors are also getting integrated.
To throw some more light on the topic that we are discussing today, we have some time till more questions pour in.
Sure, there are some questions here at Mindtree, so let me just take a couple of questions here. Are there any other connectivity protocols other than Bluetooth? So the question here from my team here is, are there any other connectivity protocols other than Bluetooth Low Energy? Yes, there are multiple other connectivity protocols. Today, there is Zigbee as a standard protocol. There are a lot of proprietary protocols today in the market. For example, there is a standard from Gartner called ANT+. So that's one more short-range wireless connectivity protocol. And there are, of course, a lot of proprietary protocols like Z-Wave and all of those that are there. There's something called as N-Ocean Alliance that is driving a different technology. There are also emerging protocols for connectivity. There's an alliance called, if I'm right, called Weightless. So that's again a new technology that's emerging for connectivity. And I'm talking about mostly the kind of connectivity that the wearable devices will use. Of course, I'm not talking about the 2Gs and 3Gs in that space. Any of these protocols you see in broad industry support, something like Apple and Samsung. So the question is, which are the standards that have very strong industry support, right? So Bluetooth Smart or Bluetooth Low Energy is definitely the one which is widely adopted today in the market. Of course, there is Zigbee in a different market segment, but typically in the wearable segment today, it's going to be Bluetooth Smart. Are there any questions from the audience
Yes.
in the webinar?
Yes, so there are questions coming in. Are you able to see them? One is from Vikas Puri. He's asking, could you say a few words on how wearables will affect healthcare for elderly?
Okay, so the question is, could you say how wearables will affect the healthcare for elderly? See, one of the today's market, or probably slightly 1 or 2 years from now, is definitely the health and wellness market, which includes healthcare for elderly. For example, in Bluetooth Smart, there are already multiple use cases that have been looked into in defining the specifications which cater to this healthcare industry and specifically for elderly care. It could be, for example, in I said about blood glucose monitoring. So you would use this to be able to monitor, and here it is also continuous blood glucose monitoring. So you are going to continuously monitor the person's blood glucose level and use that to kind of determine whether he needs a specific dosage of insulin at any given point in time. Similarly, there are heart rate monitors that are coming out. There are other body parameters, what you call as vital signs. There are 6 vital signs, including blood pressure and heart rate monitor. So all these vital signs monitoring that tell you, if you have either a chronic disease or something of an imminent attack or something that needs immediate care. So all of these are the target market for these wearable devices.
Okay, the next question comes from
And I see
Senthil
another
Kumar.
question on, is there any plan? Yeah, so I'm reading that question. Is there any plan to integrate LTE modem inside the wearable devices? Today, I don't see that happening, that LTE will get integrated in today's wearables. But tomorrow, again, not in the immediate future, I don't see LTE getting integrated. People could integrate a lot of wireless LAN, for example, because you may want the same wearable device to work at home, to work at multiple places. So the next most power efficient technology beyond the short range wireless is wireless LAN. So you could see definitely wireless LAN getting integrated in a lot of chips along with the short range. But LTE, I would think, is still very far away in terms of getting integrated. Okay, I have one more question here locally. Let me take that.
One interesting thing is context awareness. Integrate multiple devices and then context awareness. So as part of our offering, there is something like context awareness framework, kind of makes sense in our solution.
Do we have a solution? Is that the question?
Yeah.
Okay. So the question was about contextual awareness. Do we have solutions within Mindtree, or are there solutions available also in the market in terms of contextual awareness? Yes, of course, there is a lot of content and a lot of players working on contextual awareness in terms of creating, because that's a very that's what will drive a lot of the tomorrow's use cases. So a lot of people are invested in developing these contextual awareness frameworks and IP. In Mindtree itself, we have some of these more in the video space, but in terms of video analytics and all that, but we haven't still kind of brought it on to more of those common sensors kind of thing. We haven't still brought it up, but that's something that's in the pipeline within Mindtree, at least in the context of Internet of Things. We are looking at sensor fusion as one area that we will focus on. Okay, so there's one question I see here. It's as which are the biometric sensors used in wearable technologies or technologies used for gesture recognition like things? I know of a product in the market. I don't know the name today, but if you track LinkedIn and there are a couple of groups related to wearable computing where a few days back I saw a device that uses gesture recognition. It's a wearable device that uses gesture recognition for a use case that I can't remember now. Yes, gesture recognition is already coming into wearable devices. Any other questions?
So next question comes from Tilak Bhattacharya. He's asking, are the designs discussed are able to handle fuzzy logic, which typically requires more processing power?
Okay, are the designs discussed are able to handle fuzzy logic, which typically require more processing power? No, today's wearable devices are mostly about, they just bring about, it's more today, a lot of wearables today that you see are not so processor or processing intensive. It's mostly about connecting your sensor information to your host, or bringing back some of the information and alerts back from your host to your, to the person. Today's wearables are only addressing broadly that kind of a use case, not so much of, where you need, like somebody asked previously, gesture recognition or fuzzy logic that that you mentioned about. Those are still not in. So they may not be able to handle this kind of requirement.
Due to time constraint, I would request you to take one more question, and if you would like, you can sum up the session for today before we close.
Okay, I think I have no questions here locally, and I don't see any more questions on the webinar. So,
Yes,
just to summarize, I think what I covered today was mostly about. Oh, there is, okay.
Yeah, so it is from Santosh Krishnan. He's asking best IC technologies that can accept gesture inputs.
Best IC technologies that can accept gesture input. I think I didn't understand this question well enough. Is there a way I can take this offline?
Definitely. So I would share with you the questions that have been left unanswered. So you can answer them offline,
Sure.
and we will take it forward from there. So if you would like, you can sum up the session now.
Sure. Thanks, Santosh Krishnan. Let me take up your question later. So let me just summarize. So basically, what I wanted to convey today is that, first of all, understand that wearables is a completely different market today that you're looking at. Just from the diversity, from the sheer diversity that you're trying to address, it's never happened. This kind of a market has never existed before. Second thing, so if you're looking at that kind of a diverse market, then how do you really design for that kind of diverse requirements? It's easier to design if you had some 10 things, but you have 100 things requirements, then how do you design? So if you really go back and look at some of the attributes and parameters that I defined, so it's not so so difficult to actually look at this entire spectrum with a few set of parameters and then only look to address that, then automatically probably you're ready to kind of address. Of course, there will be about 10% or 15% that you may not be able to address today, but broadly you will be able to address this kind of a market by looking at some of these parameters that I put together as a framework. Really, there are a few things that today's chips are able to deliver, but tomorrow's wearables are something that very, very emerging market, and like I said, more than function, a lot of fashion, a lot of style statements will drive this market unlike any other market. So you need to be aware, and you should be prepared to kind of go beyond your own comfort levels or comfort zone of what we work today in chip industry, and be able to really work with different interdisciplinary communities to be able to address maybe what will come 8-10 years down the line. So that's the summary that I have, and thanks everyone for joining, and hope it's been useful and informative.
Yes, and I'm really thankful to our guest speaker for conducting this wonderful webinar. It was indeed a great session. And I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Santosh, for taking the time out. Have a great evening ahead.